Hey there, welcome back to another Touchdesigner tutorial. Today we're going to be looking at something pretty fun and special. We're going to be doing our first solely Kinect based project. It's worth mentioning that this project file as is, with all the functionality that you're seeing right now, is available for download in the Patreon link just below, just for a few bucks. We're going to be attempting to recreate this file today, but we may skip over a few small finer details that I've included here just for the sake of getting the tutorial to move along faster. It is worth mentioning that you will need a Kinect of sorts. There's multiple different ones, like even the Xbox 360 Kinect, Xbox One, the Kinect SDK kit, a few other options. With that said, I would like to say that I am looking into exploring alternative methods of this 3D capture technology, as it's really awesome. I know a lot of the modern iPhones have depth cameras in them, and I'm very interested in potentially developing a module for Touchdesigner that taps into this and uses it in real time. That will be for a later and future project, so if you're interested about that, please subscribe and hit up my Patreon, as I'll post some updates about it as I investigate. But otherwise, today we're essentially just going to be looking at how we get a 3D representation of ourselves in this little point cloud kind of way. And then we're going to be bringing in a little bit of noise, like you can see with a feedback loop like this, so we can sort of like paint digital paintings. And then I will basically, hopefully in this tutorial, explain everything that's going along, what's happening along the way, so that way you can take that knowledge and build off of it onto your own projects rather than just trying to copy this from scratch. But enough yapping, let's dive in. So I'm going to disable this background. So if you if you have a Kinect and have not set it up or used it in Touchdesigner before, you will need to do that. You may need to even buy a physical adapter if you don't have one for your specific Kinect. But once you do, or once you have done that, it's easy as pressing tab and typing under the tops Kinect. There's also Kinect Azure, but we're going to just be using the regular Kinect today. And we want to grab two of these nodes. You can see we have the two here like so. You can only have one instance of each of the image cameras running at one time. So for simplicity's sake, I'm just going to actually copy these two down, so like so. But you're able to just copy the steps. You don't need to do this part. So in the first Kinect, we want to set it to image depth. We want to set the image to depth point cloud, which will give us this. Uses the depth camera in the Kinect with the colors as well. And then we also want to connect in the player index. Now, just quick note about the player index. It's a Kinect's attempt to recognize human silhouettes and just render them out as such. So it's a little bit finicky. It might not work perfectly all the time. It's also limited to, I think, like 4, maybe 6 people, which probably isn't an issue. But that being said, oftentimes when I'm sitting down, it won't recognize, what the silhouette as a person. So when using the player index, you will need to position the camera in a way where it will pick you up as a person. You might need to stand up to calibrate it, lock onto you. If it's not recognizing you, that's probably why. But otherwise, we just need these two. And if you have any trouble connecting your Kinect to Touchdesigner, you just need to download all the drivers and such like that. There's plenty of resources online, but just drop me a message or a comment and I will help where possible. So what we want to do is connect this second player index one to a threshold, and we're going to set this threshold to less, and then RGB on, let's keep it on luminance, soften at 0, and then threshold, basically you just want to drag it to a point where it's actually capturing the silhouette, which is pretty easy. We just want this white silhouette here with a transparent background is basically what we're after. And then we want to combine these two layers, and we're going to do that with a multiply. So just grab a multiply from the tops here and put it in like so, which is essentially going to get the depth data of the person and then only use the silhouette. You can see it has it's got some issues here when I get too close. You might want to play around with the threshold to refine that, or just reposition the camera. From there, we're going to connect it to a math. This math is an optional step, basically. What I'm using it for later on is to just basically reposition the person. So we can just keep this value at 1 for now, but later down the line it might be very useful for sort of recalibrating or repositioning the person. We're going to skip over the feedback loop section here very briefly, and we're going to focus on rendering out the silhouette as is and sort of explain what is going on. So what I'm going to do is grab a null and leave a big gap because we're going to fill that in later. Then I want to get all of my default rendering components, but I also want to render out some geometry. So I'm going to go to my SOP and get an add, click add points, go to particles, add, connect it like so. I'm just going to double check that I have it set to, yep, as lines, and then connect this into a geometry. So we're going to be using this silhouette, or this image input, to instance a bunch of particles based off of the depth and the silhouette that we're providing. So we're not going to go into the into depth with instancing, but essentially what we are passing in here is the defined geometry for each of the points. So if you want to build a silhouette that's made up of a bunch of rectangles or made up of a bunch of 3D spheres, you can do like sphere here, and then you want to connect it to a transform, make it very small. This will be a lot more computationally intense than just particles. So I suggest doing particles and connecting that to a geometry. Then again, default rendering components. By that I mean a camera, a light, and then a render top. Now I'm going to have to manually calibrate these things like so, but you won't have to do this because I have multiple things going in to my thing. I will keep the render at 720p. Very briefly, going to connect this to an RGB key, which is going to give us a black background, and then null. Null like so, and then click this blue button to set it as a background. If it's not obvious so far, I didn't mention this at the start, I attempt to do more beginner tutorials on this channel. I don't know if my audience is like growing with me, or like what pace to increase the intensity, like if I need to keep repeating all these very beginner steps. Please let me know if it is useful for you for me to sort of break down each of these nodes, or if you'd prefer me just to kick up the pace a little bit. But yes, let's keep going. So on the geometry now, we want to go to our instancing tab, and then we want to toggle on instancing. Now we want to use this null and drag and drop that onto our translate OP. So essentially, you can see here these colors obviously don't match the real world. That's because, on a it's using an RGB scale of sorts to translate or explain depth values. Sorry, I'm still recovering from a sickness. Basically, in a three-dimensional space, the values are mapped out across X, Y, and Z, but also in this case, it's mapped out across RGB, where red is our X position, so the more red the color, the more higher along the X position it is. You can see like so. Y, so yellow is obviously up and down vertical translation, and then Z, you can see like we're mostly blue right now, but as I go back I get a much lighter blue because that is our Z index, which is how it gets all the information to understand this image in a three-dimensional context. All of that to say, we can have our null here, and then for X we want to do red, and then green we want to do green. I'm going to pause right here. It's starting to lag because I have two of these going on, which I sort of thought about before I did this project. If if I disable that geometry, is that gonna... you know what it might be as well, is we might also want to... I'm gonna quickly delete this, because this might be lagging on your end as well. We might be having a issue with the input size. Let me, for example, if I go to my multiply and then change my input to custom resolution 256, and then let's just compare these two final images. Whoa, that's because I have a bunch of feedback going on here. Let's compare the start image. Yeah, that looks about right. One of these is transparent though. Which one is the transparent one? Oh, it's the other one. Is that because we... Oh, it's because we had the math operation going on here. I don't think that math is super important. It's worth noting on the multiplier here that we change the resolution to 256 by 256 and then pixel format to 32-bit flow RGBA. Now let me try this. So R is still really not liking everything that's going on. Let me attempt to delete this. G. Oh my lord, it is not a fan. That is alright. This is a good little exercise in debugging. I can middle mouse this button to be like, okay, this is 500 by 500, 32-bit float RGBA, 250 30-bit float by RGBA. Is it our particles? Are they causing us an issue right now? If I plug this one in, and this one, and then R. Oh, it was our particles. Okay, that is good to know. Sorry, I'm a little bit ad hoc with how I fix things in all of this. Basically, I think if I go to particles, yeah. And then do I have to... No, I don't need to set the limits. That's interesting. Okay, so I have on the particle here all these parameters set. You might want to pause the video and just copy these as well. Importantly, I think bringing down the birth rate here will be quite important. Yeah, that birth rate was quite high, which is causing many particles to spawn, but we definitely don't need that. So I'm just going to plug in this original particle here, and if you want to copy my exact parameters, they are like here, like so. And now back to our geometry tab, we can do instancing of R, and then G, and then B. And then cool, we have a very evil, dark silhouette of me. A few reasons why. One, we need to define a texture. So under material, we can do a point sprite. It's just a very good default white texture like so. You might want to turn on blending, transparency, and deform, and then maybe bring the alpha down a little bit so it has a little bit of transparency. Secondly, you might want to adjust the camera. So you might want to bring it forward like that. Alternatively, on the view FOV, you can bring that forward like so, until it sort of sits at a position you're comfortable with. This math is a good opportunity to play with this math scale as well. Like I said, sort of find a good balance of everything. And then in terms of post-processing that I had going on, I just had some feedback edge and then bloom. I'll add a bloom very quick, which both sit under palette up here on the top left, and then bloom like so. But again, like I said at the start of the video, I'm not trying to exactly recreate what I showed at the start. I just want to get the fundamentals down. But yeah, this is essentially how we use 3D information from a Kinect or depth camera to translate it into a point cloud. There's absolutely no reason why you couldn't, for example here I've just turned off the multiplier, and what this has done is it's looking at this depth camera, this raw depth camera input, and being like, oh hey, let me also render the whole room. Obviously we have a few different things going on with our math and such here, but if I zoom out, you can see my whole room is now being rendered. So there's no reason why, if you don't have a depth camera, why you can't exactly just do that, and then maybe you also want to have a threshold that's based on depth. But we're not going to go too much into that for today's tutorial. What we're going to do is look at creating this feedback loop now. But I hope this all makes sense. If there's anything like you guys are not very clear on about the tech, let me know. I think it's important that we, on this channel, I actually help you guys to understand that side of things, because that's something I think a lot of other Touchdesigner YouTubers throw aside in favor of getting more stylized content out there. But I do understand the appeal of that. Awesome. All right, let's do a feedback loop. So the first thing we want to do is, after the math, I'm gonna hide my background. It's a little bit distracting for me. Let's do insert a feedback. From this feedback, we then want to shoot off to a noise, like so. Then this noise, connect it to a math, like so, and then connect this back into, I think I'm using a add, yeah. An add, like so, and then plug this feedback into the second input, like so, like so. Let's make sure on this feedback we're also plugging both of these into our noise, so that way we use the background but also the noise coordinate map. Then we want to do an over with I think I'm grabbing, yeah, the start. So I forgot to do a null at the start, but that's alright. We can just use our math. So we want to do an over where we just want to overlay all the feedback as well as the math. So let's do the math on top and then the feedback on the bottom, which is going to give us that, well, you can see here how the feedback stays in place where everything else doesn't. And then we also want to do a null here. I've named it feedback end, but you don't need to do that. But we just want to drag this onto our feedback operator like so, which is us being like, hey, this is where the feedback loop ends. Please append everything. Now I think that is all. Now we just need to set the noise and the math. So I'm going to copy these values down here like so. Let's start with the math. I think that's a little bit easier to explain. Essentially, I've set the multiplier to 0.001, which is essentially us being like, hey, yes, add in noise to this image, but make it very, very slight, which you could see with the original, how it was, if I show it in the background, there's a slight amount of noise as it like twists off and goes off into the direction. That's just us being like very slight. If we were to remove this math, we're fucked, you know? Like, we need a very, very slight amount of it. There we go, turn that off. So that's why we have that math. And then as for the noise, the important parts is that you set the output to input plus noise. I think that is the default. You then want to have transform the same, I think common the same. And then really, well, I changed the type to Perlin 3D. And then of course you want to turn monochrome off, because we want to have three-dimensional noise. But like this part's kind of just up to you. If I now start rendering the base image, and it's a little bit weird, I think my recommendation would be like, okay, here's the original noise parameters I'm using. So let's copy them. Pause the video if you want to copy it exactly and plug it in like so. I'm also going to grab a keyboard in chop here, and then on the feedback I'm going to set it to pulse like that, just so if the feedback gets a little bit out of control I can just reset it by pressing 1 like that. So now that I've reset the feedback and plugged in this noise, you can see we pretty much have the exact effects that we had in the tutorial, obviously with a few other differences. Now there's a few things you might want to consider adding. like a level to, if we do a level like here, and then set the post opacity, if we drag it down slightly, it'll have the feedback trailing off like that. Maybe you want to have the brightness down, anything like that. I'm going to keep it as is. Let's remove that level. But yes, back to the noise. So essentially the reason why I'm not explaining the specific numbers is because you can obviously copy it, but I think it's important that you play around here and sort of look to create a look you like yourself. For example, the period, which is basically the size of the noise, if we drag that right down, you see you get a lot more jittery, but also a lot more like the noise holds its original trajectory and it just jiggles slightly like so. Whereas if I change the period to like 5, you get these massive groupings and massive swelling waves, which is quite nice. Same with harmonic gain, we turn that up, it's locking into all these places. Like it's just like wildly differently cool effects you can create just by tweaking some of these parameters. So I don't want you to just copy exactly what I have. You're more than welcome to, if that's the desired look that you like, but just by like tweaking these numbers, playing around with these sliders, going beyond the bounds. What if I want to make this exponent 10? Like I've just fucking destroyed myself. Like it's just a very good way to, you know, start to piece this all together, figure out what you like, what you don't like. Maybe you hated that, so you want to do the opposite and keep it like so. And yeah, I just totally recommend playing around with the noise in that way. But that's pretty much the entire tutorial. Yeah, I'm going to keep the original file, this one here, available for download on my Patreon. Thank you so much for watching. Please leave feedback. I'm pretty much just going to go at the pace and recommendation of what people like. If you would prefer, say, a video like this look, but like with 10 more stylistic elements, and then for me to skip over the explanations in favor of just getting something cool out, let me know. Or if you like this breakdown, slow, workshoppy kind of style, then yeah, let me know. But otherwise, thanks for watching. Liking and subscribe is appreciated, and I will catch you in the next one. Peace.